All right, so I just threw a few last things that I wanted to say here together before we sort of move into the discussion section, which I think will be very interesting today. So yeah, this is actually bringing us to sort of the conclusion of the formal talk portion of Rogue World 2024. And so I just had a few last comments that I wanted to make before we all sort of potentially go our separate ways here. So first things first, some logistical things about tomorrow. So yes, the talks are over, but the conference is not over. The workshop's not over. We have a room downstairs on the sixth floor, which is reserved from 9 to 5. Okay. There's going to be coffee. It will still be, I mean, this is still considered part of the workshop. But there aren't any talks. It is purely for collaboration with all of the new people whom you've met on any topics you think in an hour or two you could hack out a little bit and see if there's something there to do in the future. Which, at least for me, I have already sort of had a lot of conversations with people here about things that might be fun to look at. So I know tomorrow there's a plan to maybe try to do the mass budget stuff that was discussed a little bit better and just see whether or not there's anything there. So anybody who wants to join in with that should let me know. I know there's been talk about trying to compare different distributions, both the theoretical distributions, some observational distributions, maybe across different kinds of observational technique even. That would be pretty fun to see since we all are in the same room together. We can actually take the data and try to compare. And then a lot of other things as well. So I know Farzana mentioned we're going to be setting up gulls. And so if you're really interested in running simulations for Roman, we always need more people who know how to use gulls. When I say we, I mean Farzana really needs it because I still don't quite understand how to use gulls. So that's another thing that we could do tomorrow. One thing that I will say is the fact that I think the vast majority of us are trying to kind of get out of here around noon. So even though we have the room from 9 to 5, I think the goal is maybe we show up at 9 and try to make sure that we're clearing out of here around noon, a little after noon. That way everybody can go enjoy Osaka in the afternoon or catch whatever Shinkansens or flights you have to catch. So that's sort of the picture. It's easiest to sort of negotiate all this on Slack. So if you have other ideas, you can message people on the Slack and say, hey, are you going to be there tomorrow? Let's chat about this at X time. Otherwise, I would say people who are interested in working on any of these things, let's sort of congregate at 9 and then divvy ourselves up then and try to make some progress potentially. So moving on from that, I want to return to the slide that I showed actually on the first day, which was what are the goals of the workshop? One of them was encourage new collaborations, which I hope has been successful. I think I've seen a lot of people who haven't met each other chatting, learning new things, building a community of people all working on this topic. It sounds like there is some enthusiasm now to try to push on this a little bit more. People understand that rogue worlds are actually a compelling aspect of the entire exoplanet picture here. And who knows, maybe they are the most abundant demographic of planet in the galaxy, at least in your terrestrial mass range. And then finally, it was to bring the community up to speed on the current landscape. And I can only speak for myself, but I feel way more apprised of sort of the state of simulations right now, the state of observations, what we have going forward, what sort of the prospects we have for joint observations, all of these sorts of things. So I've been really thrilled just to watch all of you interact and to hopefully have made a little bit of progress on all of this. And in case you guys haven't seen it, in terms of building that community, I want to thank Farzana for her great camera and her editing skills, as well as whoever it was who took the picture. I actually don't remember who it was. Oh, not here. Well, okay. We'll hopefully they're at the banquet and we can give them a round of applause then, because for a pretty hacked together photo session, it was a good photo. It turned out really well. So with that, I was also just going to mention briefly something about the future. So like I said, hopefully we're sort of getting more people involved. This community, it seems like, is pretty on board with Rogue Worlds, but there's a lot of people out there who've never really thought about free-floating planets, and people, even in the exoplanet community, that when I bring them up, aren't even aware that we've detected any. And this is something that I think is really worth chatting with people about and getting them excited. One thing I'll also say is, having run this, I had no way of gauging what the interest would be. I had no way of knowing whether or not this is the sort of thing that people would want to do again in the future. If there is interest in that, that would be awesome, and you should let me know. I would love to get some feedback on whether or not you'd be interested in a Rogue Worlds 2025. And I will say that if there is interest, there has been sort of a soft volunteer on potentially hosting this in France, which would be kind of nice, especially if we have to convince Euclid to give us some time. We'll be right there, and we can knock down the door. So it could all work out really well if that's something that people want to do. Final thing is, you have two responsibilities before you leave for good. One is return the badge. Good. The other one is, I think I have gotten to chat with the majority of you, but I would really appreciate it if before you leave for good, you just stop by and say hi, so that I can put a name to a face for anybody that I've missed. That would be nice. So those are sort of my general concluding remarks on the program so far. But as we are now moving into the discussion section, I want to credit Premek with a topic that I think is highly relevant and which I think will stimulate a lot of discussion today. And that is sort of one final task I want us to try to complete together while we're all here. This is Rogue Worlds 2024. This is probably an order one fraction of the people in the world right now who actually think about free-floating planets and care about them. And so I think that it would be a very good discussion to have right now to say, what is a free-floating planet? What is actually a good definition that we want to move forward with as a community? There's a lot of different observational techniques to look for them. There's a lot of different things you could use to define a free-floating planet. And in my travels, I have heard a lot of different definitions of what a free-floating planet is. Now, one thing I do want to say that occurred to me last night after some takoyaki and discussions with Jeremy is I at least now understand what a bound planet is. Bound planets are just failed FFPs. That's my new perspective on this. Yeah, that's I want that on a mug. But when it comes to FFPs, which are a lot harder to define, clearly, do we want a definition based on observables, or do we want a definition based on theoretical things like origin scenarios? The way that I personally have always defined it is, did it form like a star or did it form like a planet? Problem is, then people say, well, how do you know how it formed? Well, I don't. That's the issue, right? Additionally, we have different techniques to detect these things. We've heard from a lot of microlensers, and we've also heard from some direct imagers as well. And even the observable quantities you use are completely different, right? So just saying, oh, it's TE less than something really doesn't jive well with the entire community of people looking for these things. And so, yeah, with that, I kind of want to open the floor, and I would be really curious to see if there are opinions on how we sort of want to move forward in terms of defining what an FFP is. And yeah, I'll open it up. Scott.
Two points. One is the question of, we define things based on observables or based on origins. And then we have a long-standing tradition in astronomy of classifying things. Largely when we didn't understand what caused the phenomenology of the things we classify. And in stellar spectra, for example, they're classified based on features in the spectra, and later understood that there was a temperature sequence and then a gravity sequence. And when the new class of Y dwarfs and T dwarfs were discovered, L dwarfs, there was competing classification systems. One was based on just empirical observations and one that was trying to based on theoretical interpretation perspective. Fortunately, the one that was based on empirical observations won out, and that was the basis. And the main argument there is that your theoretical interpretations are going to change, but you want a classification system and a terminology that everyone can agree upon that doesn't have to do anything with your theoretical interpretation. So that's just one consideration. I'm not saying I buy that, but I'm just saying that's one consideration. A simple proposal would be whatever we call a planet around stars or orbiting other bodies like a star or a brown dwarf or a white dwarf or a neutron star or black hole, except not orbiting. So I think practically that would mean things that have a mass between the deuterium burning limit and the largest mass you can have, the smallest mass you can have and still be spherical. Without the IAU definition, but remove the thing about dynamical varying of your orbital domain, which obviously doesn't apply. I'm not saying I'm not advocating for that. I'm just throwing it out there as something to look at.
Yeah, no, good start. Anna?
You call a free floating planet only a planet if it forms like a planet, then what would you call a 1 cubic mass object that is free floating that forms like a star?
A failed star is what I call it.
I've seen this referred to in the literature long ago as a planetar. So
A planetar?
Yep.
Oh, because like planet star. Yeah. Okay.
So a planet that forms in situ in space. That's all I guess.
Okay.
Okay.
John.
I mean, as someone who works on formation models, I think we should not use them at all. Because, like Scott said, you got to go with what you can see or hopefully measure. Because interpretations are always going to be changing. So I think the proposal of doing it with the same definition as for planets orbiting stars is a pretty reasonable thing.
Does anyone remember actually what the IAU definition is right now for? It's essentially so it's anything below the deuterium limit, but is still spherical.
Yes, right. There's so it's I have it right here. An orbit around the sun for a planet around the sun has sufficient mass to assume hydrostatic equilibrium. So that means it can be round, but if it's rapidly rotating Omega, then it can be Jacobian ellipsoid or something. And has cleared the neighborhood around its orbit. So it's dynamically dominant in its orbit. And so obviously that last one you couldn't apply to free floating planets, but you could apply the first two. It would be weird though, in some sense, because depending on where you are in a planetary system, you can of a given mass and still be spherical. You can be a planet or not, but that is removed for things that are free floating planets. But I suspect there's not going to be any definition that is really satisfactory.
Sean, do you have a fully satisfactory definition?
No, I don't have a solution, but I wanted to ask why can't we call an ejected object a free floating planet and a 1 Jupiter mass object that forms in situ a free floating planet? Refer to just the whole. It's not a planet. Oh, okay. Yeah, but why just can't we though? I mean, we can, but we also can't.
We can.
I mean, we can't.
That's what I'm arguing is that we should,
Okay.
we should just make a definition based on physical observable characteristics. Then we can argue endlessly about the interpretation.
Sure. So I'm in support of it.
Yeah. San.
So I'm on the IAU F2 steering committee. So last year we received email from Jean-Luc Margot maybe you know the recent paper on the archive by John Margot and Greg Bauman about the definition of failed planet, free floating planet. I mean, the normal planet, exoplanets. And somehow we didn't discuss this, this proposal on at the IAU General Assembly in last year, this year. But maybe it will be discussed in the next General Assembly. So that's the definition of planets in general, not only for solar system planets. So then after we define that, then by this definition, we can easily define the free-floating.
Yeah, I mean, I know the IAU does not count anything free-floating as a planet right now.
And that's the proposal from the explain working group.
Is to include free-floating planets or to not?
No, it doesn't include free-floating.
Yeah, yeah.
But that's this proposal from the working group.
For those that are interested, I just put in the archive reference to the paper. Slide region.
Yeah, so there, and so John, the blue, the Margot and the government paper, it's very interesting. So you can check.
Okay, okay. Because I mean, I personally probably unsurprisingly think that FFPs should be considered planets. I think they should be included in the definition, but
Yeah, so the paper Wolfgang just mentioned, I think that paper is more about planets in a planetary system. Like it's a more analytical way to describe what clearing its neighborhood really means. So instead of like whether the neighborhood are really cleared, it's proposing that this definition should be related to its capability of clearing the neighborhood. So it's but this has nothing to do with free floating planet, because free floating planet, the neighborhood of free floating planet is a clear definition.
well, I mean, to play devil's advocate, I was going to say, to play devil's advocate, in some sense, it definitely can clear the neighborhood because it's really easy to clear an empty neighborhood, right? So provided it's hydrostatically equilibrium and yeah.
Yeah, so, this neighborhood clearing criteria depends on your semi-major axis.
Right.
So if you just take the semi-major axis to infinity, then what you'll do is you'll bump up against the IAU definition of being in hydrostatic equilibrium. And then anything below, and so then that would define your lower limit on your mass if you're not bound to this.
Yeah, Jeremy.
We just mentioned the capability of clearing. So what if you just say you're a free floating planet and say, okay, I'll pop that planet into a bound system. Does it clear the orbit? If it does, then maybe it is.
But to his point, it's where are you putting it in?
Yeah, I mean, like
It's harder or easier to clear. No, but the question is, what is the neighborhood? Because depending on where you are on the disk, you might be able to clear it or you might not be able to. Yeah. Which is why I think Scott's point of just, it depends on semi-major axis. So just take it all the way out to infinity. It's really easy to clear that neighborhood. But
if a person wants to clear his neighborhood, the best way to do it is to like go and live out in the wilderness. So
it's just an alternate perspective on clearing your neighborhood. It's just remove the neighborhood.
it's not illegal like a lot of other
That's true.
I think that way of defining FFP is just once we have observationally, once we've observationally removed any possibility of it being bound to a star, then it's free floating static. So that would move it from one column to another, and that's it's a very definite categorization. So once we've eliminated, by observation, we've eliminated any star that it could be bound to, then you're just done.
I guess the question though is still, do you count a 12 Jupiter mass thing that form just like a brown dwarf, sure, it's not bound. Is that a free floating planet?
Yeah, and then the upper limit, I would say, is just deuterium.
Which is according to the IAU definition, right? Is the deuterium burning.
Your job's done. Now, the more subtle distinction between ones that form in situ and ones that are expelled from the planetary system, that needs another definition, and that's where I mentioned the planetar idea, or we could cook up a new name for that, right? Planets that form in situ will have one name, and planets that are just floating through space and were ejected from the system have a different name. Those are all free floating planets.
I remember we had a discussion at one
Yeah.
point about you had been trying to come up with names for those two, and you had sort of like autochthonous free floating planet and
Right.
some other thing.
I had some really good tortured ideas.
Yeah, but it might be better to have sort of a cleaner. I think Matthew has a comment.
Yeah, one of the things I want to say is I don't really care what you call it. It doesn't really matter because, you know, is it 12 Jupiter mass thing versus a 13 Jupiter mass thing, brown dwarf or planet? I don't really care. What I do want to just make sure people keep in mind is that when directly image exoplanets were a thing, when that was a new thing, all these surveys programs would just throw out any identified stellar or brown dwarf companions and then not publish them and not like allow us to do good binary statistics. So in your future work with microlensing, don't just publish things that are less than 13 Jupiter masses, publish everything that you can.
Yeah, that's fair. Scott, did you have something with that? Yeah.
Just to follow up on what Rich said, you know, you need a lower limit, otherwise you would call a moon a free floating planet. Which
Right.
Stretches the credibility, but I sort of agree with this. Like, I think a lot of energy is spent on these kinds of definitions, and I don't particularly care. But just as a devil's advocate, the argument for making a strict definition, one of them is that, you know, we use words reasonably precisely as scientists, or try to be reasonably precise as scientists, so that we all can agree in the shorthand of what we're talking about. And so it is important that we do a reasonably good job of defining what we mean. And then the other part of it that is important is the press cares a lot about whether you call it a planet or a dwarf planet or a failed star. Those are very different things. They can have very different implications for the public. And even when you're talking about grant funding, you know, if you're doing planets versus brown dwarfs, those have different funding profiles. You know,
this was actually a conversation I had over lunch, which, yeah, the point was brought up that if you say, oh, we're looking for brown dwarfs, the New York Times doesn't call you. If you say we're looking for free floating planets, everyone's excited. And it's true. And so like the funding is also tied to that. If you're getting planet funding, that's a lot different than if you're getting star funding. So yeah, I mean, there's some element there that actually is relevant in how you define this and what you count as a planet or not. I think an inclusive definition isn't bad necessarily. I think that sort of this sub-deuterium burning mass, and I guess that means we're just going to be cutting on mass effectively, right? It's sub-deuterium burning mass to hydrostatic equilibrium mass.
Well, I mean, technically those depend on metallicity or the composition, whether it's ice or rock, but for the hydrostatic equilibrium, right?
Yeah.
Vesta and Ceres are roughly the same mass, but very different shapes.
True.
So, but I'm not arguing. We should just say mass.
Okay, so you think mass is the best quantity to cut on? Okay. Yeah, well, more reasons we need mass measurements, I guess, of free-floating planets if we actually want to classify any of these things. Yeah, you can.
Yeah, so I have want to bring up, actually, this is more like a question related to
the name free floating planets. So I've seen different names, like including free floating planets, rogue planets, interstellar planets. So I will agree that just free floating planets is basically a better, a suitable name to use from now on, or do we like keep using also use other names for to call these planet in galaxy basically.
So yeah, I mean, from what I have encountered, I feel like free floating planets is like the sort of what you put in a paper. And then if a popular science person writes about it, they're going to call it a rogue world or something like that. But I think that unless people disagree, generally free floating planet is kind of the term that is used in the literature, at least. Scott?
So I want to put a plug in for Davy Kirkpatrick's
Okay.
definition, which is significant. Because if you look at the definition of the word significant, it means a solitary wanderer, which is pretty perfect in my opinion. But he proposed this many years ago. And it never
A Solivigan?
Solivigan, yes. It's a word that means solitary wanderer.
That's obscure.
It's a Solivigan planet, I guess.
A Soliv. So do I have to change the title of this to Solivigan 2025? Solivigan Planets 2025?
I think it's very clever.
Yeah, no, I like that.
Anyone could normalize it with that.
Yeah, exactly. I mean, we're the community. If we decide it's Solivigan Planets, and that's the biggest contribution Rogue Worlds 2024 made to the to the community, no, is what it is.
If we ask the exoplanet, just to use the word planet. There would be a conflict with that.
You think if we use free floating planet? Yeah, and that's one of the things that I wanted to bring up. No, and that's something that I wanted to bring up with the IAU stuff is like, so at least on my end, right? The reason that I care about origin scenarios is that in the case of things that have been ejected, like planets, right? Those are direct inputs to understanding planet formation. So in my mind, if you're applying for planet funding, it sort of makes sense to say, okay, these ejected bodies, they're actually going to tell us a lot about where planets form, the evolution of planetary systems, et cetera. And so it's sort of that makes sense to me why those two things are lumped together. I think it's more of a stretch to say, you know, I formed as a slightly sub-brown dwarf. It's going to tell me a ton about planet formation. Maybe, I mean, that could be an unpopular opinion. But so that's one of the reasons that I feel like having the inclusive definition might be a little bit too inclusive if, you know, the planet people are going to say that's not a planet. Why are you competing with us for funding? I'm just saying. I'm just bringing it up. I don't have an answer for that, but that's sort of why I've always divided it that way. Is does it help you understand planets, or does it help you understand stars more? If you were to observe this thing. Yeah, Scott.
I'm just going to be a troublemaker here.
Okay.
Because if you believe in top-down gravitational instability forming planets, then I think, you know, whether or not you can form a Jupiter mass planet in isolation tells you something about the ability to fragment and collapse. And so it probably does tell you something about planet formation.
That's 100% fair. And I mean, it goes back to your original point, which is you probably shouldn't use theory to define things, right? That's fair. Yeah, Hannah.
If we call free floating planets, then why do we call who are stellar objects?
Because it's not round, I think, is the conclusion we've come to.
They could be a free floating asteroid. Could be more consistent.
Yeah.
We're talking about an alien ship.
Yeah, exactly. A free-floating UFO. Yeah.
No, it's not free floating.
Yeah. Exactly.
Well, that's how heavy load.
Yeah.
It seems to me that the object's sphericity, departure therefrom won't be observable in most cases, so that it's not, it won't be helpful to add that as part of it. And then another thing that occurred to me is there are probably 13 Jupiter mass objects that have not yet ignited. And so they haven't started deuterium burning yet. I remember that from one of our talks. So, but on the lower end, what I'm suggesting is that on the lower end, we can just have like a mass cutoff. There's one thing we can observe, or at least compute, is the mass, but it's whether or not it's spherical or it's a little royal-looking object is immaterial. Most of the time, we won't be able to tell even.
May I
I mean,
ask?
you can set a math threshold at either one.
Yeah.
Either end. I mean, your deuterium burning, that's not at a fixed mass either. Right. So, you pick a mass that is based on, deuterium burning, but you actually just use the mass. You don't determine the metallicity, determine its history. If it forms really slowly, it could be, 20 Jupiter masses and not burn deuterium.
That's a good.
Same
point.
thing is true
Yeah.
of the hydrogen burning.
Yeah.
Yeah, and so, it's maybe a bigger uncertainty with whether it's going to be spherical or not. But
Can I ask a dumb question? Oh, sorry. Go.
So pretty much anything that's self-luminous, just say that is in this group. Anything that's not just that's giving off its own light.
Well, everything gives off light,
yeah,
except for black holes.
Well,
They give off light.
hey,
They give
watch
off
yourself.
light.
Watch yourself there. My dumb question was, why is Pluto not a planet? Is it because it doesn't clear its
Yeah.
local area? Okay, so it's spherical, but it doesn't clear its. Okay.
It's not even the biggest of its kind.
Okay, I'm not arguing. Look, I'm not going to get into that. I'm not going to wade into those. Yeah, I was just trying to double check that I understood the definition. Matthew, did you have a comment?
No, I think we covered.
Oh, okay.
Yeah, I want to keep asking this question. What if we found a bunch of free floating Pluto? Do we call them free floating planets or free floating dwarf planets?
I think given the definition we're running with right now, those are free floating planets because they were lucky enough to be somewhere where it was really easy to clear the area.
No, they're free floating planets because they're probably round.
Yeah.
But I mean, there is the area clearing thing, and I thought the idea was you. But then Pluto becomes a planet again. Oh, so it has to be unbound.
For bound planets, you keep the
Okay,
clear
okay. I'm sorry. I'm trying to keep up here. There's a lot going on. Yeah. All right. Kukuba-san.
Yeah, first of all, yeah, I agree with Matthew. I didn't clear up so well. I agree also with Pago. So my AI found this the definition of industrial objects by IAU. So an astronomical object that is not gravitationally bound to a star and is in industrial space. So this can include asteroids, comets, or rogue planets, but not stars or stellar remnants.
What is this definition?
My AI said this IAU. IAU defines it as stellar object. So it's yeah, we have Oumuamua and
Right.
And it seems IAU has defined industrial object. And so then it seems the FFP is a kind of subclass of industrial object, right? IS.
But I'm not going to start calling this ISO 2025. You know what I mean? I don't know. Like, I think that's too big of a.
But that's industrial objects, right? I don't dislike industrial objects.
Yeah, QI.
And what if it used to be a moon instead of a planet, so that the mass distribution may be different from the planet?
Oh, if you were a moon around a Jupiter and then you got liberated?
Yeah, and after that, it rejected.
I think still a planet, still a
Yeah.
free-floating planet,
The idea is to be,
as we don't care about the origin. Yeah, we don't care about the origin.
You could have binary planets that liberated as well.
Oh, but those are bound.
Well, until they're liberated.
No, they're bound to each other. They're
I
bound.
know, I understand
Oh.
what you mean, but they can be unbound from each other.
Are bound FFPs? Sorry, are binary FFPs? Does that still?
Jumbo.
If jumbos were to be jumbos, would those still count as FFPs? Because those are bound to each other. I mean, you nod, but I thought it had to be unbound from something.
I'm bound to a star.
Not bound to a star or brown dwarf. Okay. Okay.
With the Terran brain.
Yeah. Okay. So not so you can have systems, but so long as nothing is bigger than 13 Jupiter masses.
Star bound with black hole. Any condensed object with mass greater than
Okay. Okay. Jeremy, yeah.
So what definition can I write in my notes?
Yeah. I think that, I mean, okay, we were never going to come up with like a totally complete definition here. This is just for discussion. But I think that for the most part, if I had to sort of summarize, it sounds like people are generally comfortable with an observationally driven definition, not a theoretically driven definition. And that possibly just adopting the notion of anything below deuterium burning, so say 13 Jupiter masses, and above hydrostatic equilibrium, so you have to sort of assume a model there, but there's going to be some lower mass threshold, provided it's not bound to anything that has above 13 Jupiter masses, is a free-floating planet.
Star.
Bound to any star or brown dwarf, or white dwarf, or black hole, or neutron star.
So what about things that form in disks that become 14 Jupiter masses and are then ejected? Why do we want to remove this as a free floating?
Do they start burning?
Yeah, exactly. Like, what's the utility of rejecting something like that? Because
We don't know what happens.
Because yeah, we don't know the origins, I guess.
I mean, we're trying to figure out ways to figure out the formation mechanisms of these types of things, and we think we can place some constraints. So let's say, for example, we find a 14 Jupiter mass thing in a star forming region that we have evidence that it was formed in a disk. Would we call that a free floating planet or not?
You would write your proposal to change the definition. And spend 10 years of your life arguing about it.
I mean, it's a fair point, though. I mean, it is a yeah.
So
Let's go.
I mean, let's think about this, right? If you have a 15 Jupiter mass planet, 15 Jupiter mass object orbiting a star, right? We wouldn't call that a planet. We'd
No,
call that a
Brown dwarf. Yeah.
So if that thing then subsequently gets liberated, regardless of how it's formed, then we would still call it a brown dwarf.
Yeah. Yeah. If you're burning, yeah.
Again, the goal is to just have a common terminology that we can all agree on what it means when we say a certain word, right? And then we can talk about later what, the particular contributions to that class, where they came from, what caused it.
Yeah, but the concern with something like that is when you have a 5 Jupiter mass thing forming through, or with 13 to 5 Jupiter mass, whatever, people automatically assume they have to form within this. So then, like, this is kind of the one of the things that I'm worried about when it comes to this is just how people perceive it when they're not directly in this site.
Well, I mean, this kind of thing happens. Already, right? You see, theorists writing papers saying that things that form by core accretion are planets, things that form by gravitational instability of brown dwarfs, and say, well, they may overlap in mass, but this is the physics. And you may You can have the official definition, and then if you're writing a theory paper, you can say, well, this alternative method makes more sense for explaining, physical processes or something like that. And, people are doing that already. So.
Yeah, and people do that, but I think the problem is that people throw things out or ignore things because of strict definitions that people place on things. So like a deuterium burning limit or the hydrogen burning limit, a lot of people throw things out sometimes in surveys because of those definitions. So I'm saying I think we need to be careful about making strict cutoffs or something, because in the future, people will use that as a reason to like set a metric or set up a sample.
Well,
Yeah.
I mean, if we don't set a strict definition, then we're going to make a definition and when they write, decide what's appropriate for their paper.
Right, and that's why I'm saying we should not be as strict if we are talking about papers. We should have a little bit of grace.
I think this is just a fundamental limitation of classification of anything, right? I mean, people classified living organisms by, kingdoms and phyla and whatever. Turns out that the genetics of that was completely independent of all those classifications, right? So I think that you can abuse classification systems like any other thing that you do in observational astronomy. And so you just have to be careful with that. But it doesn't mean that you shouldn't be pretty clear on classes that you define, right, on what they mean, so that everyone can agree when I say an A star, what that actually means, or an M star, what that actually means. That's the argument for doing observationally driven rigid classifications.
Right. My only thing is, if we're going to do a rigid thing, we should make sure everyone knows that that we shouldn't make strict cutoffs. Like that's all I'm really saying. Like if we require that it has to be 13 Jupiter masses, people are going to use that in their work in the future, and we should understand the implications of that before trying to set that.
Yeah, I'm sensitive to that. I also think that the 13 Jupiter mass thing, there was a pretty good, like, if we're going to agree on anything, that's a pretty good one to agree on. Just because, like, that's already sort of how people consider brown dwarfs versus planets. To your point, if it formed bound to something, if it was 15 Jupiter masses, we would have considered it a brown dwarf, right? So I think that's fair. I think that's still fair.
I mean, it's kind of a coincidence, though, that I mean, there's no physics that relates the Turing-Burning limit to. I mean, it doesn't make the physics of it any different, whether it burns deuterium or not. Not related to how it forms or anything like that. It's just a number that you come up with that's about in the right location.
But at the end of the day, like, you could also argue what's a brown dwarf, what's all of these things. If we already have agreed that brown dwarfs are a class, we're going to classify something, right? And planets are going to be.
No, so but it's it's a semi-random choice of something because it falls in the right place and it says definite value or almost definite.
And so I think we all agree that the definition is going to be arbitrary.
Sure.
It's going to be arbitrary. It's not going to be perfect. But in terms of arbitrary definitions, I do think that this is not an unreasonable one.
Sure. I mean, it's already a definition for, bound planets or bound brown dwarfs. You might as well
extend it. Yeah. And then I guess to the IAU's point, currently free-floating planets are just not considered planets at all. They're considered, planetary mass objects or something like that. I do think that they should be counted as planets, but some people would argue that planet necessarily means bound. So it's subjective is what it is, but I personally think that well, maybe this is the wrong audience to try to make this case to, because I think we all are probably in favor of that. But yeah, I mean, I think these count as planets. Free-floating X planets. Well, no, that means they were a planet once.
Yeah. No,
yeah, you can't do that. Okay, well, are there any other comments on,
What we talk about is different topic.
okay, do you have one you want to suggest? Okay, no, that's fine. Well, so yeah, so then let me just conclude with, all right, I actually think that was kind of productive because I at least am going to stop using only the sort of theoretical prescription that I was before. And it's nice that we are all sort of on the same page here. I'm gonna credit Predmec again with suggesting this topic because I think it was worth discussing. We have the room for only 15 more minutes. So, is there anything else that, as this day winds down, people want to bring up, or are there any sort of sub-projects people want to advertise to hack on tomorrow morning? If not, I would say we should probably start cleaning up the room and then migrate towards the banquet hall. Food is served at 6. Yes, Natalia.
So, yeah, I really enjoyed this 45 minutes of what the pre-floating planet. Yeah, I think that our main issue of this conference is how to detect the free-floating planets and how to study them. So please, when you leave, think of that and not about how to call them. And if free-floating planets is something that you're going to put in your when you're asking for time, and this will give you time for telescope, put free-floating planet, please. Thank you.
Yeah, no, and let me echo that actually. That yes, to Natalia's point, this was an entertaining discussion to have and one that I think was fruitful and stimulated a little bit of discussion. But at the end of the day, I was really happy that we concluded with Natalia's talk because it did really drive home the fact that these things are really hard to observe. There's great science you can do with them, but they are notoriously difficult to observe, which is why we have not seen very many. And which is why it's a really exciting time to be getting into this field because we will see them in the future. The question is, how much science can we do with them? And if we want to maximize the science returns from something like Roman or Earth 2.0 or any of the upcoming direct imaging things, I think what our responsibility is as people who attended this is to go out and say, yeah. So we've decided on a definition, but more importantly, these things are extremely impactful. These things are going to tell us stuff about planet formation that we otherwise would not be able to probe from early dynamical, histories that are otherwise pretty much difficult to ever observe. And that if we want to actually get any science out of this, you should give us telescope time. You should do joint observations. You should talk to communities who've already gotten some expertise on trying to do imaging and stuff. That I hope is the thing that you all walk away with. And I wish that I had been keen enough to bring stickers like Hano that all said, rogue planets are important, that you could stick everywhere and get people focused on this. So yes, thank you for bringing us back to that. And so with that, maybe I should close out the formal part of this and say thank you all for being here. Thank you all for contributing. And thank you all for the contributions that I'm sure you will make in the future.